Welcome, digital ship friends. We are opening a webinar. I'm glad to see more and more of you connecting to this live session. Also, I'm glad to welcome you back to the second season of Digital Ship webinars. We kick off with a very interesting topic, transforming weather into a strategic advantage for vessel operations, that we put together with OrbitMI and DTN, who appears as sponsors of this webinar as well. So I'm happy to introduce you with our guest speakers. Please welcome Adam Stahl, Chief Commercial Officer at OrbitMI, Jarco van den Brink, Senior Product Manager at the DTN, and Slavisa Djokic, who is VP of Engineering and Head of Product at OrbitMI. Carl Jeffrey, founding editor of Digital Ship, is moderating this discussion, and I invite him to introduce us to today's discussion.
Okay, thanks. So what we're going to talk about today is how we can use weather data more broadly in the operations of a ship and how it can be a source of strategic advantage for the company. Now, there's nothing new about weather data itself, but what we're presenting today, which is new, is the idea of having appropriate weather-related data, which is automatically delivered to the right people at the right point in the workflow on the software that you're already using. So as an example, if you're managing a voyage, if you're on board or on shore, you can get an alert that says that the weather has changed and the vessel you're responsible for is no longer on the optimal route. If you're involved in scheduling or planning, so that could be the bunkers, the vessels themselves, crews, the berths, the financials, maybe you'd like to have advice that because the weather conditions have changed, the vessels is going to be delayed and your schedule will have to change and the fuel consumption is going to increase or other financial impact. Now, having more granular weather data is a part of it, but that's not the main part of it. The main part of it, well, perhaps, is having the right weather in the right part of your workflow. So you want good integration with the digital systems you're using and the weather information and good analytic and collaboration tools to work with it. And the weather information is coming into the apps you're already using rather than having to switch between different apps. So that's what we'll talk about today. We've got two companies that work together, OrbitMI, which is a software as a service company, and DTN, which is a weather company. So OrbitMI provides cloud-based software which can be used to support workflows and decision-making. They're based in New York, but they're a spin-out from shipping company Stena Bulk. They also focus on chartering, commercial data analytics, vessel performance management, and sustainability. And we're going to hear from Adam Stahl, who's the Chief Commercial Officer in New York. DTN is the company is based in Minnesota, but we're going to hear from Jarco van den Brink, who's the product manager based in Enschede in the Netherlands. They do subscription-based service for delivering and analyzing real-time weather. And then after Jarco, we'll go back to Orbit and we're going to see some ideas about the potential use cases of how we use weather in operations, including optimization on the fly and alerting for operators, better voyage planning and chartering intelligence, which is from Slavisa Djokic, who's the Vice President of Engineering. He's in Niš in Serbia. Then we should have time for questions. So please load your questions up in the Q&A box at any time. I'd like to invite Adam to give the opening talk. Thank you.
Thank you very much, and appreciate the invite, and thanks for everyone for attending. Good morning, good afternoon to those around the world. So today our compressed agenda is to talk a little bit about the DTN and Orbit collaboration, and a special shout out to the senior leadership at DTN, our support through Jarco, and then Heis Harmons and Mike Rivette, who are also very instrumental, and Steve Craigs in our collaboration efforts to bring innovation and improved use of data in the maritime ecosystem. So we'll talk a little bit about the collaboration. We're going to promote this, what we call share to gain values in maritime, which is about collaboration and partnership and innovation and bringing companies and technology and data together so that we can all work faster, more efficiently, and work from the most informed information to make a decision in the role that we sit in within our organizations. We'll discuss a little bit about how weather has been used traditionally, and then demonstrate ways in which weather data can be used in the future, and that future starts today. So that's our agenda, and I'll pivot a little bit just to talk about Orbit. itself. We were launched in 2019. We're a spinoff from Stena Bulk. Stena had unique challenges around vast amounts of technology and wanted to develop a core solution that helped them run their business more efficiently, more effectively, more informed, and developed Orbit, which was eventually commercially spun off in 2019. So Orbit is a maritime workflow and business intelligence solution. We are a SaaS, we offer SaaS and DaaS products, and our core offerings revolve around maritime intelligence, chartering tools, compliance, vessel tracking and notifications. We have routing solutions and noon reports, and through our collaboration with DTN, we'll have even more features and core competencies that we can deliver to the marketplace. One of the beauties of Orbit, outside of its core competencies and the tools and modules that that Orbit can deliver to you, is that we have a very flexible integration architecture. So outside of Orbit's powerful core, we recognize that there's a lot of great technologies in the ecosystem, such as DTN, and we have the ability to take components of external systems and visualize that inside of Orbit to the persona of the user who has to make a decision. So it's not about integration, it's about innovation of the data so that the person who's sitting in their chair in a maritime business or on a vessel can be informed and make decisions off of a single source of truth. So this is all about speed, and it's a tough conversation to have. You know, how do you look yourself in the mirror and look at your business and say, you know, am I working at the optimal speed? Am I working the most efficiently that I can? Am I making the most informed decisions? And that's where Orbit plays in the ecosystem, because our core technology is very powerful. Its integration layer is also very powerful. And when you bring those things together across your entire technology platform, you're able to do your tasks and the role that you sit in much faster. So Orbit is about a single source of truth. It eliminates multiple logins. It reduces displays on a whole bunch of screens. Many of us have been working from home for many months, and if not now, we're going on multiple years. So we all have our command centers of all different screens and laptops and iPads and phones. And this is about condensing that so that you can work more efficiently, faster, more informed. It eliminates cut and paste and double entry of data. We minimize spreadsheet overload. We're delivering real-time data with actionable insights for people to make decisions. And at the end of the day, Orbit, in collaboration with DTN and our partner ecosystem, is about uniting technology and people so that you can make decisions faster. That's the spirit of Orbit. That's the spirit of the collaboration between Orbit and DTN and our partner network. So today we have Slavisa and Jarco, who are going to talk a little bit about weather data, things that are available, how we can illuminate it, so that we can leverage technology and display that to you in everyday scenarios. So we'll talk to you a little bit about operator use cases, chartering use cases, and general maritime intelligence that now can be unlocked instantly, in particular with our collaboration with DTN. So with that said, I want to turn it over to Jarco. And again, Jarco, thanks so much for your support. And we look forward to your component of the presentation. And thank you so much again for your time over the last several months.
Thank you, Adam. Thank you. Yeah, I want to take the opportunity to do a quick introduction of DTN as well. I'll just read out the sentence. DTN is a data analytics and technology company that delivers actionable operational intelligence to organizations with complex supply chains. So that's, I would say, in one sentence, where DTN stands for. And we are helping Orbit to integrate our intelligence and our data and to bring that added value to the end user, where it creates those seamless, I would say, user experiences. DTN is not only active in shipping, also in offshore energy, aviation, transportation, sports and safety. So you see that in the bottom being mentioned. Whereas we also can cross data sources and use the intel from other industries, from adjacent markets in our decision-making products. First, I want to dive a little bit into detail on weather, because that's also one of the topics that's being integrated in Orbit. So let's start a little bit off with what DTN is doing. It all starts with atmospheric forecast data. So DTN has atmospheric forecast data, which flows into the modeling of the oceanographic data. So we have a whole oceanographic data modeling system. Important to mention there is that there is a continuous feedback cycle. So we harvest data from satellites, buoys, but also from masters who kind of report on the vessel how the situation is at sea. And that's, I would say, a constant feedback cycle that loops into our system together with the master mariner expertise. And we are able to do that accurate modeling. Whereas I have to say that also, especially near shore, it's getting difficult. Near shore, you have all kind of effects, diffraction of the waves between islands, like in this example here, but also shallow waters, tidal information. So that's all being modeled in some extra nearshore modeling, where some extra accuracy is needed to resolve kind of those difficult questions. So what comes out is a comprehensive data set with more than 500 maritime parameters, global resolution, and high frequency update times. So that's, I would say, the base on which the weather data is being founded. Resolution, I already mentioned it. It's important. Let me explain a little bit why. So you see here on the left side, lower resolution, on the right side, a higher resolution. That's also how the model is operating. And actually the model has a land-sea mask, meaning that the model is looking at some parts in the model. It determines that it's land. On the other hand, it's sea. And the calculations that are going along with that are different. So it's important to determine the land-sea boundaries. If we remove the background, you can clearly see that the lower resolution, the English Channel in this example, is hardly noticeable. Whereas in higher resolution, it still is resolvable. So also the calculations are of better quality. And if I then lay on top that DTN has ultra high resolution, and this is an example of the port of Rotterdam, where you see the data points as it's being delivered, and where, like mentioned in the previous example, we have the ability to locally scale it even up in that nearshore modeling to resolve really the difficult cases near shore. Is that all important? Yes, but what's more important is the total package. And that's, I would say, a little bit the point that I want to make with the slides that I just presented. So we have, I would say, a good forecasting base. We have update frequency, resolution, and parameters that actually are making sense for the use case that needs to be covered. But that's not only it. You also need to have, I would say, the output needs to be fit for purpose. Either it's map layers, you want to show it on a map, in this example in Orbit, or use time series or gridded data. So those are all use cases that need to be supported. So what's important is that data covers the full package. It needs to be fit for purpose. And like Adam has mentioned, a single source is important in order to avoid, I would say, any duplications, or at least duplicate information that contradicts. All, of course, to deliver the situational awareness. Well, on top of that, DTN is also delivering some actionable insights around decarbonization topics and performance data. Yeah, and I can only, I would say, also stipulate what Adam mentioned, is that bringing that all together in Orbit into the user's workflow is then, I would say, the true value add. Our DTN expertise around weather, around some value add services, around decarbonization and performance, and bringing that right into the user's workflow. Now I want to switch gear a little bit. We talked about the weather. Let's talk also about routing, because that's a little bit of a second use case. And later on in the presentation, Slavisa will also show some of those use cases in Orbit that he will show. So this is an example of routing. The black line is the shortest route. You see the great circle across the ocean. I think this is an example from Houston to Rotterdam. Whereas also there is the weather optimized route, which is the green line. And you can see some differences where the weather optimized route wants to make advantage of the Gulf Stream and actually ending up a few hours early. It's a longer voyage, but it spent less fuel and it's actually earlier. It will arrive earlier in the harbor because of that, using that kind of conveyor belt of the Gulf Stream. So that's where I would say weather routing is about. And let's dive also a little bit into that topic. So I want to at least pinpoint a little bit the maturity curve of vessel routing. So where are we coming from and where are we going towards? So at the start, we have basically our common or best practice routes. That's how the master mariner would sail an ocean crossing. And then there are differentiations in wintertime or in summertime, if you go a little bit more north or stay south. But those are the most common routes, best practice routes, that have proven value in order to come safely from A to B. But those are not taking into account the actual conditions, like weather conditions. Same with common routes based on AES trends. That's basically just following a kind of the bulk of vessels who are traversing the oceans in those lanes. Also not weather optimized. Next step is, of course, to take weather into account. So avoiding heavy weather, taking actuals into account, which is basically weather routing. So with the start of your voyage, look at the weather and try to come up with the best plan. If you go to a next step, and that's basically weather optimized routing, where you are using weather, but also the performance information of a vessel in order to calculate the weather optimized route. And that will be of least of best economical efforts, or either you will improve your timings, your fuel consumptions, or be safe to the environment. So that's a little bit the curve of evolution in routing. So weather optimized routing, what are the real benefits of that? Well, there are basically four main pillars there. And let me discuss straight away the kind of benefits there. It's, of course, cost savings and improved operational efficiency. Then you can think of fuel consumption that you can reduce. You can reduce your daily hire cost of the vessel and get some more reliable ETAs. Reduced environmental impact. Also, due to the lower fuel consumptions, you actually can achieve your sustainability goals, get better greenhouse gas ratings of your vessel. And also, for example, go more with variable speed instead of slow steaming. And with a variable speed, you can take into account weather conditions. That if a heavy low is impacting your route, you can speed up a little bit and later it's slowing down. So you can be more smart on that. Increased voyage safety, I think that speaks for itself. If you do a weather optimized routing, you want to try avoid heavy weather conditions and be prepared for heavy weather conditions. And last but not least, improve the overall vessel performance to take advantage of favorable currents and winds that will you can use basically as a conveyor belt. So those are a little bit summarized the benefits of weather optimized routing. Well, DTN has a solution for that. That's which will calculate the route. But again, it needs to be fit for purpose, and no vessel is the same. So again, just like with the weather data, you need to make it fit for purpose and have the configurations to control as a user in order to set your preferences. And that's where it comes in. These are some of the functionalities that the routing API of DTN has to its capabilities. So you can set, for example, the optimization types if you want to arrive with a late can window, or you want to optimize on fuel costs. You can fill in the vessel characteristics to do that weather optimized routing and take the performance of the vessel into account, because no vessel is the same and it behaves differently on waves in particular situations. Route network, quite important as well, because the routing API delivers a safe navigable route, and especially near shore, and you see that in the example picture. And there are some rules and some navigational rules and some notices that you need to take into account. And basically the route networks make sure that in those cases, the vessel will sail a safe navigable route towards the destination harbor. You can set no-go areas if you want to avoid some specific piracy areas, which are sometimes even company specific. And of course, you can put in weather limits in order to avoid certain conditions that are too high for the vessel. So again, I want to emphasize that it needs to be fit for purpose in order to work in the user flow. And again, integrating that in seamlessly in the user interface saves a lot of time and clicks, especially when you take into account the fit for purpose parts where it will cover the needs of the end user. Slavisa, I would say a small demo from your side, right?
That's great. Thank you, Jarco. Maybe I can share the screen. What I would like to show you are a couple of the use cases that actually brings all these things that Adam and Jarco was saying, and how these systems that are dealing with the complex data can be structured in that way that can actually provide the ingredients for the resolving the workflows on a daily basis that are occurring in the maritime world. So a couple of the use cases, and everything is better with the visualization, I guess. So let me share my screen, and maybe we can start with the use case number one. And yeah, before we go there, I would just like to introduce you to Orbit and say about something what you are seeing here now. And this is the dashboard of Orbit, which all of our users are seeing. And here I have selected a couple of the vessels that are under that I would like to overview, that I would like to track constantly. So I can see right away where my vessels are, where they are headed, are they laden or ballast. I can see which area they are. So let's start from there. And of course, as usual, when we see something red, that is something that is in need of my attention. So I'm going to pick the vessel here, and I'm going to click on it. What we are seeing now is actually the voyage of this vessel, where we are showing all these informations that are coming in actually to Orbit, and that are showing to the operator a simple presentation of the voyage and where the vessel is and what is expected to happen. Right away, we can see what actually caused the notification and the alerts on this vessel. And this is the alert that I actually got on my phone as well, on my Orbit mobile application. So in this case, I have a notification that is notifying me that ETA will be delayed by 4 hours due to rough sea. Now, the first thing that I'm gonna do to check this is, of course, to check the weather and to check what kind of weather is expected. And I can definitely see that there is a rough weather ahead. So the second thing that I'm gonna do here as an operator is actually try to find the more optimized route so that we can make the ETA. So I'm gonna click on this link here, and right there we are visualizing actually the changes in the route that was predicted to happen with the route that is more optimized now with the data that we have from DTN. And we can see that the vessel is bypassing the bad weather and the rough sea, and that it is actually trying to make the ETA with this kind of observation. Now, the visualization of this is one thing. However, the thing that actually drives this visualization and the workflow that I just show in this case is actually the integration with DTN and capability of crunching all of this huge amount of data into a structured inputs toward the system such as OrbitMI, where we can actually use that data and in combination with others data, help operators resolve their challenges very fast. As Adam explained, speed is crucial here. So we are capable of resolving the thing that, resolving the event that happens and that is causing a delay right away. So having said that, this is the first use case, and I would like to show you two more. So let me switch to second use case, which is a bit different. However, it is using the power of weather routing as well. What you are seeing here is actually the voyage calculator, and the voyage calculator is showing the route that I want to check, and this can be used on the deviation of the voyage. However, it can be used also to plan specific leg of the voyage entirely, as I did here. So in this case, the first thing that I did was actually entering the Houston and Rotterdam port and starting the calculation for the route based on the orbit routing, which is calculating based on the finding the most optimal distance based on the historical data. What we are seeing here, of course, is the distance that we are covering, the consumption that is expected to be consumed on this leg. And we are also seeing the arrival dates, the departure dates based on the first initial arrival date for the Houston. Now, this makes sense, and this consumption estimation is very good when we are taking the legs that are in the future. However, in order to get even more close to get this on the next level, as Jarco explained with the weather, I'm going to try and turn on the weather condition here and see what kind of weather is expected actually down that leg. So as I see that there are weather conditions that are appearing here, I'm going to choose not to go with the shortest route, but to go with the most recommended route based on the weather data. And I'm going to recalculate this. What you will see here that the route change, of course, the waypoint change. However, something that is very interesting that Jarco was also mentioning was that even though the distance has increased, the consumption has actually slightly decreased. And that is because in this way, the vessel will be using the best route in order to use the most out of the weather, not to go against the weather. So in this case, the vessel will be consuming less and doing more. Of course, this is not always the case that happens, of course, but this is a great way for the operators who are doing the deviation of the voyage or the chartering persons who are planning specific leg to get a better insight of something that is upcoming, that is something that basically to have a better way of estimating consumption on the upcoming voyages. So this is the second case, and I have one more case to visualize. I will not go any further than that.
So the other thing to add here as well is that a lot of times we find that people use arbitrary weather factors as just a sort of general directional thought, and that we can also we have the ability to layer in sea margin, which actually impacts the ETA. So it's taking in historical averages based on the voyage and calculating that into the equation versus using a 5%, 10% directionally correct. We don't really know. That's just the number we've always used. Takes that out of the equation, and we can integrate the sea margin data into the calculation.
Thank you, Adam. Maybe I can switch to case 3 now. And this is in the previous cases, we try to visualize the the weather routing in orbit. Now I want to speak about one more thing that weather can actually bring into these kind of insights of the performance overview of the vessel tracking. So in this case, I would like to check one vessel that is actually the vessel that is out of my scope, that is out of my company, where I want to have a better insight of how the vessel was performing, what the vessel was doing, and to see if that vessel is of some fit into some need on my side, and to see if that vessel is something that is capable of maybe even doing specific workflows for me. So let me check. Let me click on the vessel, and in this case is Bowery vessel. So what Orbit is displaying right away is actually 1 month, and we can change that to have 6 months of data or 1 year of data of the AIS track, where we can see the pattern that this vessel had in the last month. And you can see that Orbit does already some calculations based on the AIS data, based on the vessel particulars, where we can determine with a certain precision where the vessel was laden, where the vessel is laden, where the vessel was ballast. And of course, we can determine the itinerary of the vessel. Based on that, we can definitely find out what was the efficiency of the vessel, how much the vessel was efficient into the given time frame. However, now taking that to the next level, and that is what else can we say about this vessel. And based on the weather that was going on, that happened on this route that I'm explaining here in 1 month, we can see actually that vessel, we can assume what vessel was actually, what kind of speed did vessel have. And now this vessel speed comes in two ways, right? So one is speed over ground. That's something that is widely known via AIS. However, there is also speed through water, and that is something that we are capable of determining now with DTN, because we are capable of knowing what was the weather impact and what that impact was on the speed of the vessel. Now, this is the current status of that vessel. However, more interesting for me is, of course, to see how the vessel was doing in the last month, so we can see what was the change of speed through water and speed over ground, and closely connected with that, what kind of weather effect actually caused that. And we can even go into the past and see, okay, maybe I can turn on the weather layer first, so we can see what kind of weather was there. And now I can actually check what happened on the specific date when the weather effect was a bit low. So I can go on that date, which is 18th, back into the past, select it, and see exactly at that time what was going on. So I can see the difference in the speeds that was were reported, and of course I can see, of course, 1 month of data again in the past. Now, this is something that this visualization is actually explaining a lot about those kind of vessels. However, this really gets a whole new level when we are talking about the vessels that are reporting, that the vessels that are in company that are owned, so or operated. So in this case, this kind of benchmarking of that data that is coming in from the vessel or the vessel performance itself can bring additional layers, not only of benchmark, but additional layers of validity to the data that are coming in from the vessel. So with that being said, I will stop my screen sharing.
Oh, well, that's fantastic. We ready to go into the questions? Yeah. Okay. So this is a Q&A time for this session. So you can load up questions into the box below. I've got a few to sort of get started. I mean, one of the things I was most interested in, maybe for Adam, is the kind of commercial. How do you sell this, or how does somebody buy it? I mean, I think the shipping industry is used to buying very sort of vertical things, specific things like weather data or a new engine, and this is kind of a horizontal service where you buy I guess Orbit is kind of cutting across a lot of areas of shipping and different bits plug into it, isn't it? Which must be quite a different way of buying software to the ones that people are used to. But do you want to maybe talk? What would a typical customer look like from this? And do you think?
Yeah, so that would come in two shapes. You could have an existing DTN customer who's interested in enriching their DTN subscription inside of Orbit to gain more value of a consolidated single source of truth. So there's one level of customer type. And then there's customers that we talk to directly that are interested in routing or weather services or some layer of data feed that comes from DTN. And we can illuminate that inside the Orbit subscription. So we have multiple ways to work with DTN through the Orbit layers and working with DTN or existing DTN customers who want to consolidate the power of the combined systems to work faster.
Right, because Orbit, I mean, the strength is in the commercial data or how you support people's commercial activities. So I guess they need to use Orbit for that to get the value of the two systems together, would they? Or...
Yes, that's correct.
Okay, so we've got a couple of questions coming in about where the data comes from. This is something we always get. I think it must be the biggest problem that shipping companies have. And I know that the whole point here is a very fluid data structure where you can capture just about anything, but I'm not even sure which of you is the right one to answer. But so Bo Feely is asking, does your data come from noon reports or sensors on board the vessels? Andrew with RightShip is asking, you're getting emissions data about NOx and SOx. And Duncan is asking how often you update the weather. I've no idea who's the best person to answer these because we're kind of crossing over the technical and weather routing. I don't know who would like to.
Yeah, so at least from a DTN perspective, I can say that then noon reports can be ingested, but those are proprietary, right? So if you insert noon data or VDR data, then the output is enriched with the fuel data, for example, that's being reported in the noon reports. But that's only available for yourself, because we are not mixing up, of course, those data streams. So you have the ability to send in your, I would say, your own proprietary fuel data or noon report data, but that's then only available for you as that particular user. And that has then also the carbon emission figures, CO2, NOx, SOx figures. But that's only when fuel data is being reported. Otherwise, it's hard to get that across. Updates of the weather at the moment, 4 times a day, where I mentioned we have that feedback loop where observations are taken into account as well. So I think those are 3 questions in one go. Yeah.
Yeah, and from an Orbit perspective, we have Orbit offers its own noon reporting tool, which can be used standalone or can be used as an integrated solution inside of Orbit. And it's also open in architecture, so there's API feeds in and out, so you can leverage the Orbit reporting tool to be delivered to multiple technologies, including Orbit. And as it relates to just data in general, while Orbit is a very powerful tool out of the box, because of our rich integration layer, we can also take information from, again, other third-party sources and bring and build the system that a customer wants to operate in a single source of truth. And Slavisa, I think, can also tag on to some other comments on that sort of broad question.
Yes, maybe starting from the top, can you please advise whether the system has the ability to capture NOx and SOx, as well as pure consumption? Of course, the consumption are the basics for the and those emissions are calculated based on those pure consumptions. NOx and SOx requires also additional elements and vessel particulars, of course, and we are capable of providing those. So yes, we have the basic capture of NOx and SOx as well.
Yeah, it might be worth explaining how Orbit works, because as I understand it, so you're kind of a sort of platform layer, software as a service to the cloud, and then specialist companies can plug in. So if somebody has a model of a great way to work out what the NOx is based on knowing what the engine is and the fuel consumption is, then you'll connect with that over cloud service. I don't know if you want to explain that in better than I have. I just note for the audience, we've got a lot of questions now. You can actually upvote questions. So with that thumbs up sign, then we can see which questions you're most interested in if you'd like to. But otherwise, we'll just start from the top. Yeah.
As for these questions, you're completely right. So how Orbit does is actually it combines the data from different sources. And in this case, the data from different sources are actually coming in. One from vessel particulars, other from reported data, could be from sensor data as well. So what Orbit does is actually combining those in order to make the calculations. For the NOx and SOx, of course, the engine types are very important, and in combination with the reported data from the vessel and sensor data from the vessel, that actually gives us the ability to do the calculation for those.
Okay, so we're going back to Jarco now for the question from M. Moshnoi. I think that's Norwegian, perhaps. So he's asking where your weather data comes from. I guess you're yeah, you can breathe. Is it coming from NOAA or European EC? Or?
So I did not dive into detail of that, but DTN has, of course, a long track record in weather forecasting. So yes, we have our systems in place. And what I try to explain is that we have a system which is doing the atmospheric modeling. So we are using indeed sources like NOAA, ECMWF, doing a specific, I would say, I'll call it blend of that in order to create our DTN proprietary forecast, which, by the way, is outbeats in verification, for example, NOAA and ECMWF. And what we are specializing to do for the maritime market is that we are using the atmospheric model in order to drive the wave modeling, because winds are actually driving waves per se. So, and we want to make that consistent. So our wave modeling, so our oceanographic modeling is in line with the atmospheric modeling. So it's also a kind of consistent set of data.
Okay, so maybe we go to Slavisa for Alessia's question. So I think what's important here is people understand that it's a platform, not a sort of particular functionality you're selling, I suppose, because she's saying, can you compare emissions from the same ship? How have we improved the emissions after a dry dock, or how does this compare with that? I suppose the answer is yes, but maybe not with Orbit, maybe with another specialist platform plugged in, or is that the kind of answer you'd give there?
You're correct there. So the Orbit is filled with reporting tools that are capable of providing the reports that are needed. Those reports can be structured in any way that it is needed. For instance, you can select one vessel, you can select the range or the voyage, and basically do the performance overview of that vessel. Then you can do that in different range. You can do that for multiple vessels in the same range. So there are quite a few possibilities that can actually give you the performance of each of those vessels, and you can do that into Orbit. You can export it from Orbit. You can share it in or outside of Orbit if it is needed. So quite a few possibilities there.
Okay, so Ollie Nielsen is like to get a stick question for your second use case where you were showing a sort of static weather map, but of course the weather is going to change over the voyage. Was that just because it was a demonstration, I guess?
It was the demonstration purpose because we wanted to put different use cases into this one, for use case 1 and for use case 2. First use case was actually meeting the ETA with weather routing, and exactly what Ollie was asking here, and that is how we can use this powerful service, how we can use this great amount of data to actually meet the ETA. That is the goal, one goal. And in second case, I wanted to visualize how actually we can consume less on the same distance. So I hope that answers the question.
So we're going back to Jarco for a couple of weather questions. I'm not sure we got a specific answer about the updates of the weather. Is there a sort of time, looking at Duncan's question, a sort of time interval you update? And then Shahbaz, who's with OSM Ship Management, I think, is asking which data, meteorological data, do you think is most accurate of all the sources? Do you want to take those two at once?
Yes, sure. So typically the model that we have is updated 4 times a day. If you look for shipping use cases, and especially, for example, for routing use cases, I would say typically once a day. An updated weather optimized route advice makes sense. I think those are the typical skills or time scales to think about. But if you like, you can do it 4 times a day. So 4 times a day, there is new, I would say, data available with the latest accurate accurate data in it. And whereas DTN is applying that weather data in the routing functions that I showed in order to give that extra value to the users and predict those ETA calculations. You can imagine that if it's sensible or at least sensitive to know the exact ETA, then it might be wise to do it 4 times a day and update.
Okay, so Shahbaz, ECM, European Centre for Medium Range Weather Forecasts. Is their data more accurate than other models? Do you want to say? This might be getting into commercial stuff now.
Well, so ECMWF is considered to be one of the top models out there, but it depends also on the region, right? So it depends on which geographical region you are. So it's a difficult question. I would say in Europe there are several high-resolution models, lower-resolution models. So it's a difficult question to answer. What I want to say is that at least DTN is taking, I would say, into account all those models, blending it in a kind of best blend. And that's basically the proprietary forecast that DTN provides, which, like I explained, where we are calculating the waves with all the features like the coastal corrections and the high resolution coastal phenomenons that we can kind of resolve as well.
Okay.
The other thing, Carl, if I could just add, as it relates to synthesizing the weather data into the previous question around the weather changes during route, the Orbit and DTN collaboration also helps on the market intelligence side as well. So if you're looking at a TZ vessel, you're looking at your own vessel, you're competing for a cargo, again, it may not be the closest vessel, it's the most optimal vessel to choose to compete or consider for TC. And because we're integrating the C margin into the calculation tool, Orbit's routing tool has point-to-point, point-to-port, point-to-point, port-to-port sort of capabilities. And then we're layering in the C margin to then understand estimated ETAs based on practical weather data that's being synthesized inside of Orbit versus arbitrary weather factors. So again, another differentiator in when you're thinking about making decisions and sort of where you position vessels or what vessel is best positioned for a cargo.
Okay, so we've got 2 meaty questions about crew now. So Ollie Nielsen is asking, are you giving the optimization information to the crew? And Vishnu Ravindranathan is saying often it's quite hard to get the crew continuously interested in this stuff. I think by ship users, he means the crew. Do you want to, maybe that's right?
Yeah, so I can comment on that. So the weather optimized routing that we're doing, there is a speed advice. So you can set a kind of speed range the vessel is capable of operating in, and then you get a kind of advised speed back from the system. So that's also what's being, I would say, delivered to Slavisa and Adam and visualized then in Orbit for the users to interact with. So every data point has metadata, and one of that is indeed the instructed speed, as we call it. Yeah, and then maybe next question around how many days ahead. Yeah, so I would say nowadays, forecasting especially, if you get that continuous feedback loop where you try to improve the system with actuals, I would say the first days are of course the most accurate, and after day 7, day 8, things are getting uncertainty kicks in. So that's also why we also with the whole routing, the first days are I would say more important than the last days. So that's taking into account the uncertainty, but there is uncertainty information available as well. So also you can say something about the spread of uncertainty, so to say.
So Vishnu's added another note. He meant continuous internet on board. So does the crew need to have, if the crew don't have an internet connection, can we still use it? Maybe that's for Adam and Slavisa, is it?
The reporting of on the vessel, of course, one of the goals of Orbit is actually to bring the data from vessels to shore and to make that, to do that automatically, so the users are actually capable of viewing the data and working on data right away after that data was entered on the vessel. in those cases when the vessel doesn't have the continuous connection to internet, and that is perfectly fine. Orbit Reporter in this case, maybe I can explain that, is a tool that actually not predicts that, but actually is capable of doing the offline report that is being automatically sent as soon as the vessel gets the internet connection.
Okay, there's an interesting question in the chat box from Serkan Ozturk. He's asking about charterers. So this is the first time we brought this into the discussion. So if the charterer is saying something about the performance, that you didn't do what you promised, can Orbit make a performance report you can give to charterers? Is that for Slavisa to give?
I can take it. So this, as I mentioned before, Orbit is capable of providing all kinds of reports that can be even customized. So this kind of customization reports, or actually the report that we have in Orbit, are generated from the data that is coming in directly from the vessel. So from the real data. Now, this can be used in many ways. Our customers use it in many ways for compliance, for determining the performance. So this is one of the way how this real data, since it is there in Orbit, it is one of the ingredients of all of the workflows that we are having, is, yes, this is something that can be done.
And I guess for added context on that, the reported data that's coming into Orbit through Orbit's noon reporting tool is actually then compared to the actual weather hindcast to that point in time. So Orbit is very good at comparing different data sets, whether it's AIS data, voyage management, noon report, weather data. It's comparing information constantly. So we can take the reported data from the vessel on Orbit Reporter or third-party reporting tool and compare it to our DTN integration on the actual rendered weather that occurred at that point in time.
Oh, okay. We've got 9 minutes left, and we've got 4 questions, but 2 of them are the same. So Mark Andre and Nicolaus are asking about integration with the ECDIS or Vessel Traffic Management Information System. How's a route plan integrate with that? And Andrew Rightship from Rightship is asking about if you're predicting the speed, particularly if the ship has an engine power limit. So maybe should we go to Jarco for the routing one, and then maybe to Adam for the speed one?
Yeah, so Andrew, that's a good question. So, and I think I tried to elaborate a little bit on it with the variable speed. So you can imagine that if you do a routing, you have the ability to set a speed range, meaning that you can say my vessel can operate from 0 to, or maybe 2 to 50 knots. And if you optimize on fuel, then it will try to seek the least amount of fuel. So trying to meet your energy efficiency kind of index as best as possible. So if you optimize then on fuel, what the system then tries to do is basically first maybe outrun bad weather, and then when it's in good weather or high pressure, it will try to ease down and save on fuel. So it's smart enough to determine that. Advise, for example, to go 10 or 11 knots at the start to outrun that low pressure, and afterwards ease and go at slow steaming to still be as cost efficient on fuel. So that's some capabilities that the system is having.
Okay. What about we've had lots of cybersecurity webinars to talk about challenges integrating with ECDIS. So do you want to maybe that's for Jarco about how? I suppose you can't export a route plan to an ECDIS, can you?
I think so. The API is delivering the data to Orbit, to Adam and Slavisa. It's a little bit to the front end how to facilitate that. But I know that there are RTZ files that's commonly used in ECDIS files that can be imported and exported. So I would imagine that something is possible there. But that's more on the I would say user flow side rather than the brains and the intel that DTN is providing. Right?
Yeah, and I would say, and Slavisa can talk the technical terminology, but through a lot of our recent conversations, there's this dream building concept, which is what Orbit is in business to help build technology dreams, of synthesizing the planned voyage, the weather optimized voyage, and the ECDIS voyage, sort of all consolidated in one view. And so there are technical capabilities to do that, in part in our collaboration with DTN and with other providers, to render those paths visually inside of one system. And I'll let Slavisa talk more of the technical terminologies on how that can work. But that is absolutely something that has been brought to a dream building concept that let's solve for this one, because this now would keep everyone uniformly in the business informed on what's going on with the vessel.
Exactly. I can just add, on the beginning of this Q&A session, we were talking about the vessels, the data coming in from the vessel, from sea to the shore, and how we are analyzing and visualizing that, of course, in resolving workflows. However, this feedback loop, I guess, from the shore is very much important. It's actually making a circle. When something happened, someone reacts to it and proposes a solution back to the vessel. So this is definitely one of the points that we are working on, and there are few possibilities there, limited by the, of course, vessel connectivity and limited by the ways of transporting that data, but the data is there, which is important on the shore and can be transported to the vessel in a email or different kinds of means.
There's an interesting question for Mr. Mossenhoy or Mr. Mossenhoy here about if you get a rerouting every 4 hours, perhaps that's too much. But I suppose that's also something that the client can set how often they want to be rerouted. Is that I don't know if anybody has any comment on what's the optimum rerouting frequencies, or whether it matters from a technology point of view. You're on mute, Jarco, I think.
So yeah, well, I would say it's a little bit up to the user. So I can imagine every time you have a new position of the vessel, you're able to calculate a new optimum route. If you do it more often, there will be less changes with the previous route. So if you do it in 6 or 12-hour times, there could be some deviations because more and fresh data comes in. But already with position updates, you get kind of accurate information of where the vessel is. And you can kind of calculate a new route, and like mentioned, you can play with the settings as well. So maybe close up some passages if you don't want to pass certain passages, or so those are possibilities in order to do rerouting. So it depends a little bit on the use case there. I would say every time a new position comes in, there could be a possibility, or it could be a use case in order to calculate a new route.
And on the Orbit side, Carl, and audience, we can customize the alerts and notifications based on the preferences of the customer. So whatever the threshold or ranges are based on the alert or notification that we're triggering to someone's desktop or mobile, that's all custom configurable. So on our side, it's user preference.
Oh, that's fantastic. Well, we've got 2 minutes left. Slavisa,
sorry, Carl. And just to add there, of course, the kind of period, the frequency of optimizing the route, or statistically looking on a larger scale, is definitely something that is not as frequent enough. But it gets very, very much important on the specific events that might happen on the voyage. In those cases of the event, in those events, actually rerouting can, like Jarco mentioned, a couple of those, is very much important. And it is very important in that case to have the freshest data as possible so you can work with it.
Yeah, Jarco, do you want to take Shahbaz's question in the last 1 minute, the maximum range of the forecast? I think he means in advance in time. Is it, can you go 2 weeks or more than that?
Yeah, so our forecasts are 15 days, but those are the marine forecasts. But we have different, I would say, data within DTN. So we also have monthly forecasts, which are more seasonal forecasts. So it depends a little bit on the use case again. If you talk about the maritime use cases, it's often 15 days in advance that we can look, and after that, usually I would say more climatology is being used in order to say something reasonable on what's going on.
Oh, it sounds great. Well, I think we're coming up to the hour now, and thanks everyone for some great questions. I had quite a few warm-up questions. I only needed one. That's fantastic, and I shall pass back to Vida for the closing words. Cheers.
Thank you. So you've heard how OrbitMI and DTN works together and transforms weather into strategic advantage for vessel operations. Digital Ship is hosting our annual 17th Athens conference next week, and we have a number of webinars in the pipeline for October. Just keep an eye on our website for the updates. And now Digital Ship is signing off. Take care. Bye.
Bye-bye. Oh.